Okay, this is the interim study guide, so I'm going to go through as much as I can. Okay, we have a motion graph here. This is a velocity versus time graph. Okay, and it's asked which section is the acceleration the greatest. Okay, so with velocity versus time, our slope is acceleration because our rise is our change in velocity. That's along our y-axis here. And our run is our time. That's our x-axis. Okay, so rise over run gives us slope. And for this type of graph, that value is going to give us acceleration. So let's look at these different sections, okay? This section is on 0, so that's not going to have any slope. That would be an object that is at rest. Okay. This section also at 0. This is a flat section along, it looks like 30 meters per second. So this is going to be a constant velocity. So no acceleration in either one of these. These two both have a slope. Okay, and so I'm going to guess that this one has the greater acceleration because it looks steeper, but I'm going to go ahead and check it. So let's see, if I go from 0 to 30, that's my rise. So I'm just picking some points that are easy to use to do rise over run. So I go from 0 to 30, and then this run here looks like it's from 5 seconds to 8. So I'm going to have 30 minus 0 over 8 minus 5 gives me 30 divided by 3, gives me 10 meters per second for that section. That's BC. Okay, and then DE. Now this one is got a negative slope because my rise is really kind of like a fall. I'm going from 30 to 0 here, so I've got 0 minus 30. And then the run looks like 12 to 18, so that would be 6 seconds. Minus 30 divided by 6 gives me minus 5 meters per second. Okay. So BC is going to have the greatest value. This is a section where we're speeding up, okay, in a positive direction. And in this section we're slowing down in a positive direction. Both of those are positive because we're above the 0 line. Remember, with velocity versus time, when you cross over this line, you're changing direction. Okay, so above it is positive, below it is negative. Okay. Alright, looking at the list, which is scalar and which is vector. Okay. So speed is a scalar. Speed is like if you look at the speedometer on your car, and it just gives you a number, but you don't know about direction. Velocity is a vector because it is a how fast you're going, so your speed, but also with a direction. Acceleration is always a vector. That's how much our velocity is changing, and since it includes velocity, which is a vector, that makes acceleration a vector. Time is a scalar. It's just a number with a unit like seconds. Distance is a scalar. Distance is how far we went, like in length-wise, but not thinking about direction. And then displacement is a vector. This one is how far we went, but including direction. So it's a difference between a starting and an ending point. Okay. In a vacuum, which has a greater acceleration while in free fall, a bowling ball or a feather? Remember that both these objects, if they're in free fall, they're going to be under the influence of gravity. It's the same force of gravity, which is going to cause the same acceleration due to gravity. And that's going to be the same 9.8 meters per second no matter whether it's a bowling ball, a feather, a Volkswagen Bug, a tiny paperclip. I mean, it doesn't matter. They're all going to have that same 9.8 meters per second per second. Mass does not change the acceleration due to gravity. So both objects will have the same acceleration. Okay, and then this one, this person held the women's world record for the 400-meter run around an oval track with a time of 47.6 seconds. So we want to know what was her average speed and her velocity during this race. Okay, so speed is a scalar. We can get that just by dividing the distance she ran by her time. I don't know where my calculator is, so I'll just use my phone. So 400 meters divided by 47.6 seconds gives me 8.4 meters per second. So that's her speed. Her velocity, that's going to use her displacement, which is our difference between our starting and ending point. And in the case of a track, if you're running around the track, you're going to start and end at the same point. So her velocity is actually going to be 0, because she started and ended at the same point. Her distance was this 400 meters, because this is like, picture a track. Okay, so she starts here. She's going to run around this track. That's 400 meters. 400 meters in 47.6 seconds is 8.4 meters per second. That's her speed. But her velocity, she starts here, runs around, ends at the same point. So when we take direction into account, she basically went in a positive direction and then the same amount in a negative direction, or in an opposite direction, and then her displacement 0. She's still, the time's still the same, but her displacement is 0. Okay, so that's the first video.